When we think about artificial intelligence, we picture something super modern, almost science fiction, right? But what if I told you that its core intellectual DNA was actually written down thousands of years ago? Well, today we're going to uncover that secret history, the one that connects ancient mathematics to the AI that's literally shaping our world right now.
So let's go way, way back. I'm talking long before anyone had even dreamed of a computer, let alone data science. We're in an era where big, complex problems had to be described just using words. Imagine trying to solve something when the solution is all tangled up in long sentences and maybe a few rough sketches. It was messy.
And it always starts with a problem. A real-world puzzle, a challenge that just needed an answer. The thing is, the tools to solve it in any kind of systematic way just didn't exist. Until, that is, a huge discovery was made. A discovery that basically gave humanity a brand new language.
And this was it. This was the breakthrough. This wild idea that a confusing, messy, wordy problem could be boiled down into a clean, elegant structure of symbols. I mean, think about that. This simple act of translation, of going from chaos to clarity, well, that was about to change everything.
Okay, so this wasn't just a small step forward. This was a completely new way of looking at the world. It was the birth of a language that could describe not just the things we can see, but the hidden rules that govern pretty much everything, from how the planets move to how much a loaf of bread should cost. So, what is this language? We call it algebra. The word itself comes from the Arabic algebra, which means the reunion of broken parts. I mean, how perfect is that? It's a tool that takes a fractured problem and makes it whole again. An early pioneer, a guy named Diophantus of Alexandria, was a huge champion of this, using symbols for unknown numbers to create a real system for finding answers.
And the process they came up with was just brilliantly simple but so powerful. First, you just state the problem in plain language. Second, you build a model by translating those words into equations. And third, you just work those equations. You rearrange them until the answer pops out. This simple path, problem, model, solution, that became the intellectual engine that drove centuries of discovery.
As you can imagine, a way of thinking this powerful wasn't going to stay limited to just number puzzles for long. Nope, it expanded, and it became the fundamental language of science, giving us a real framework to understand and even predict how the physical world works.
And this core idea just kept growing. From its roots in ancient Greece, algebra got more and more systematic. Then, bam, the scientific revolution hits, and you've got people like Newton using calculus to explain motion. Fast forward a bit more, and statistics comes along, giving us the tools to find patterns even when things are uncertain. With every single step, math just became a more powerful engine for figuring out our universe.
So, let's jump to today. We are now facing a totally different kind of universe. It's not one made of stars and planets, but a universe made entirely of data.
I mean, we are just swimming in an unimaginable ocean of information, generated every single day. And just like those ancient astronomers who saw what looked like chaos in the night sky before they found the laws of physics, we see chaos in all this data. But we know, hidden deep inside, there are patterns and insights just waiting to be found. And to explore this new universe of data, we turn to a very familiar path, one that was actually forged thousands of years ago. The tools might be new, they might be running on silicon, but the thinking is ancient.
I mean, just think about this parallel for a second. Physics asks, how does the universe work? And it uses the laws of nature as its models. Data science asks, what patterns are in this data? And it uses statistical models as its tools. The medium has changed. We've gone from the physical universe to the data universe, but that fundamental approach is exactly the same.
And look, it's that same three-step process all over again. You start with a problem. You represent it with data and a model. Then you solve that model to find an insight. The intellectual path we're on today is identical to the one from so long ago.
So here's the classic form, right? A simple, clean equation. The whole goal here is just to figure out the value of that one unknown, x. You're just trying to find the one number that makes the whole statement true. And now, look at this. This equation is fundamental to a modern neural network. Yeah, it looks a bit more complicated, but the core idea is shockingly similar. In machine learning, the model is basically just adjusting its internal dials. Those are the weights W and the biases B, over and over again until its output matches reality. It's still just solving for the unknowns. So, when we zoom all the way out, from those ancient scrolls to today's supercomputers, we can see that the real purpose of mathematics has stayed exactly the same. It has always, always been about one thing.
And that's this. Mathematics is the art of transforming problems into structures that can be solved. It gives us this incredible power to take something that's messy and confusing and turn it into a puzzle that we can actually solve. It really is the art of finding clarity in the middle of chaos.
Which kind of leaves us with one last big thought to chew on. Is what we call AI, or data science, really some brand new revolution? Or is it simply the latest, most powerful chapter yet in this epic story of human problem solving? A story that began thousands of years ago with the simple, world-changing idea of algebra.